Okay, so today for day 2, we're going to be talking about significant figures. Oh yeah, doesn't that sound fun? Maybe you did this in chemistry, or at least supposed to at least. So this tells you which parts of a number are important. There are a couple rules. These are all the rules you're ever going to have to worry about for significant values. Now, the first one is easy. It's all non-zeros are going to be significant. Let's give you an example. Here's a number, 234. How many significant figures are in this number? There are 3. There's a 1, a 2, and a 3 significant values in that number. Beautiful. Okay, there's another one. The only thing we have to worry about for all of these is zeros, okay? It's all the zeros' fault, I promise. But zeros between other significant figures are also going to be significant. So, to give you an example, something like that, if you have 101 dogs, you have way too many dogs, but you also have 3 significant figures in that number. You've got 1, 2, 3. The 2 ones are going to be significant, and the 0 between them becomes significant because the 1s are significant. Okay, that one's pretty easy too. Now let's get to the fun stuff. Extra zeros, or sometimes called optional zeros. Okay, so let's say they're zeros that you didn't have to write, but you did anyways. So let's say you've got $3. How many sig figs are here? The sig figs are going to be 3, because you've got 1, 2, 3. Okay, there's 3 sig figs there. Because you didn't have to write these numbers, but you did. Okay, you could have just written 3. Now this has 1 sig fig. If you write 3.0, you have 2 sig figs. You get the gist. It goes on and on and on. Now, if you write something like 10.0, let's stick with the zeros. This one is going to have 3 sig figs because this is significant, and this is significant, and this one's between them, so it counts 2, right? That's rule number 2. Okay, this is the only exception here. Do you see this big capital and underlined word here? Placeholder zeros are not significant. What a placeholder zero is it's just a 0 that moves the number over to the left. Okay? For example, 100. How many sig figs are there? There are 1. These zeros right here don't do anything. They're just saying that the 1 is in the hundreds place, not the tens or the ones. So there's only 1 sig fig there. Okay, we'll give you another reason to help you out in a second here. But I wanted to hit this number, the last rule first. Placeholder zeros before a decimal are going to be a significant. Now, let's say you really had 100, okay? Exactly 100. And you needed to specify that with 3 sig figs. What you would do is you would write 100 and you'd put a decimal point there. That decimal point is telling you that it just so happens to end at 100. Okay, so you have a 1, a 2, and a 3 sig figs for that. Okay, what if you needed something between? What if you needed to express a 100 as 2 sig figs for whatever reason? Okay, what you'd have to go to is your old friend, yes, scientific notation. All right. Remember, for scientific notation, it's going to look something like 3.00 times 10 to the 8, some famous number like that. Anyways, there's 2 parts to scientific notation. There's this part here with the 10 to the, and then there's the number in front that's always between 1 and not 10. All right, this part's the one we're worried about, the first part. It's actually got a name. It's called a mantissa. Do you have to memorize the name? No, but I like to. It's a cool word, and you can show off to your friends. But anyways, what the rules are for significant figures here are significant figures are anything that you would write in the first part of scientific notation. Now, this should make sense because this rule right here, placeholder zeros, these numbers don't go in there. These numbers just increase the exponent on the 10 to the. All right? So if we wanted to write this number here, I know we got arrows going anywhere now. So 100 with one sig fig, it's just 1 times 10 to the 2. Whereas this guy right here is going to be 1.00 times 10 to the 2. Okay, so that's the changes there. Now, that's going to cover you most of the time. But there is a special rule for discrete numbers. What's a discrete number? A discrete number is something that's countable, something that has, like in a series or a sequence here, you've got 1, 2, 3, 4, no in between. Right? So if we counted people in the room, you can have 3 people in the room, you could have 4 people in the room, but you cannot have 3.5 people in the room. Even short people get the full value here. So countable means that there's a distinct number, and it's exactly 1 and exactly 2 or exactly 3. That's why they have infinite amount of sig figs. Because if you said there were 5 people in the room, that number isn't just 5. It's 5.0000 on forever, right? So that's why it's exactly 5. The rounding doesn't exist. It's rounded for all values to 5. All right. So why does this matter? Because we're going to do math with sig figs. Okay? So there's 2 sets of rules. First rule we're going to talk about is for multiplying and dividing. Most of your math is going to be multiplying and dividing with these guys. All right? Now remember, multiplying also includes squaring too, because you're multiplying it by itself. But anyways, whenever you multiply and divide, you keep the smaller amount of sig figs. Okay? Let's do an example here. Let's say we've got 3.00 times 2.0. Spoiler alert, the answer is 6. Now, this guy has 3 sig figs. This guy has 2 sig figs. Your answer needs to have whichever one is less. In case you weren't sure, 2 is less than 3. So your answer should have 2 sig figs. So your answer will be 6.0. Ta-da! And that's it. So you have to be able to pick out the sig figs like we did before, and then combine that with multiplying and dividing. So you're just going to round it to whatever value it is using those sig figs. Okay, rounding works normal. There's no fancy stuff for rounding here. So let's say we do another one. Let's say we've got 3.00 times 80. Okay, can you multiply these ones together? Let's see if you did it right. All right, 3 times 8 is 24, so 3 times 80 is going to be 240, right? But let's think about how many sig figs we have. So this guy has 3 sig figs. This guy has 1 sig fig. 1 sig fig is awful. You always want to avoid it. I was mean and I gave one to you. Sorry. So 240 isn't really what our answer should be. Our answer should be 200 because it needs to have 1 sig fig. Okay, I know you're crying right now because 3 times 80 is not 200. But here's what's going on. These numbers are rounded off, and so this is what you're allowed to say based off of that rounding. We'll talk about the grown-up version of sig figs after we do adding and subtracting. So we'll get there. We'll get there. We'll give you some consolation here. So let's do adding and subtracting. Now, for this one, it's got a slightly different rule. For this one, we're going to keep the smallest place value of significant figures for both. All right. So let's talk about this here. It's easy with an example. Let's do one together. How about we do 3.00 plus 2.0? Okay. So Spoiler alert, the answer is 5. But what we're going to do is we're going to throw off sig figs until we get to the place where they don't share a sig fig. So we're going to have 5.00. That's if you added it normal, but this guy is not significant because there's no 2. There's no unit here for the 2. So this is where the 10ths place here is where they both have significant figures. So your answer is going to be 5.0. Okie dokie. So let's try one more, see if you can do it. So we're going to have 17 plus 3.1. Go. Let's see if you did it right. If we added it up normally, we'd have a 1, a 0, and a 2. Carry the 1. Easy. Okay, but now let's look at sig figs. The sig figs here is going to be right there because the 17 does not have a decimal. So this decimal here doesn't really matter because we don't know if it's a decimal. It wasn't 0.0. So the answer is going to be 20. But you can't write it that way. That's only got one sig fig. Throw a decimal point in there so that way you have the 2 sig figs that you need. Oh yeah, did I get you? Maybe. We wanted to do some readings here. The last thing, because you're going to be reading these off a scale. Where this shows up in place is for reading it on a ruler or just an experiment in general. Whenever you do a reading, your sig figs goes one value past the printed lines. Okay, so let's do some practice here. I've got 2 rulers here. Okay, so this ruler is trash. I mean, look at it. So if I was measuring the pencil goes to about here. So what would I say if I'm measuring it in decimeters? Ooh, decimeters. It's going to be 1 point something. What is it? I don't know. Maybe a 2. I'm looking at the ruler below. I'm cheating actually, but that's okay. Now that's going to be your answer. That's what you're allowed to say because it's marked to the whole number, and yet 1 past that is going to be in the 10ths place. So that is going to be your answer in your lab report or whatever like that. 1.2. Now if you're measuring it in this guy here, draw a nice straight line. These lines go to the 10ths place, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this time we're going to have 1 point, oh, I think it's a little shorter than 2. I'm going to say 19 decimeters. Do you see how we can have another decimal point since this is 0.1, this is 0.2, this is 0.3, etc. And so we can go 1 past that to the hundredths. Now it might feel weird because you're eyeballing it, but you know, that's the way the cookie crumbles. So let's measure a straight line. This line is perfectly straight. Don't be deceived. See if you can tell me how long that is in centimeters, please. Let's see if you did it. So I know it's more than 4, and it's going to be a decimal point after that. So it looks like this line's a 2. Does it go past there? I don't know. 2.21 centimeters? Looks fine to me. So that's what I would write on my. Now what we want you to understand is what you're really saying underneath there. That way any of those fringe cases will get covered for you. So what we mean by that is when we're saying sig figs are 3.0, what we're saying is that we know it down to this level. This is known, okay? Now, there's other ways you can write it. Maybe you've seen it written this way where it's going to be 3.0 plus or minus 0.05, okay? Now, the reason why we know this is because if it were somewhere between 3.05 down to 2.95, all right? Because this would round up to 3 and this would round down to 3. So it's somewhere between those, what we don't know. That's what we're really saying when we say 3.0 here. Now, the more sig figs you have, the smaller this part becomes and the less important. So having more sig figs means you have a more exact value for the number compared to just about this or that. All right? So this will help you to understand what's really going on when you're doing more complicated things like your square rooting or whatever. So, or doing sine or cosine later on. So don't worry too much about weird operations when you're doing significant figures, but this is what's happening underneath, and you'll learn much more about that when you do a quantitative analysis class in college. I know you won't be able to wait, but that's okay. All right, so that's it for today. We'll see you tomorrow. Like and subscribe.